This is a most important lecture on the most important issue of our times and all time. The topic is global climate change. The lecturer is Dr. John Holdren. The title of his lecture is Meeting the Climate Change Challenge, and he has been given this lecture to scientific audiences at least since 2006 with updates. Dr. Holdren's qualifications and positions speak for themselves. He is one of the most eminent scientists in the world today.
I'm going to start by summarizing the main messages. The first of these messages is that I think we in the scientific community have made a mistake by allowing the term global warming to capture the title of this problem. I think global warming is a misnomer because it implies something that is gradual, something that is uniform, something that is quite possibly benign. And what we are experiencing in climate change is none of those things. It is certainly not uniform. It is rapid compared to the pace with which social systems and environmental systems can adjust. It is certainly not benign. We should be calling it global climatic disruption rather than global warming. Second key point is that disruption and its impacts are now growing much more rapidly than almost anybody expected even a few years ago. The result of that, in my view, is that the world is already experiencing dangerous anthropogenic interference in the climate system. Many of you will recognize that term in quotes as part of the text of the UN Framework Convention on Climate Change, which was agreed to, signed by the senior President Bush in 1992, subsequently ratified by the United States and 190 other nations. That convention embodies the goal of avoiding dangerous anthropogenic interference in the climate system, and it is my contention that that goal is already out of reach. We are experiencing dangerous anthropogenic interference by any reasonable definition today. The question now is whether we can avoid catastrophic human interference. We need a price on greenhouse gas emissions. And the final key point is that the United States has to switch from being a laggard in addressing this problem to being a leader, and we need to switch sooner rather than later if the world as a whole is to act in time to avoid catastrophic interference in the climate system. Climate change governs, and as a result, climate change affects the availability of water, the productivity of farms and forests and fisheries, the prevalence of oppressive heat and humidity, the formation and dispersion of air pollutants, the geography of disease, the damages that we have to expect from storms, floods, droughts, and wildfires, the property losses that we have to expect from sea level rise. The Earth is getting hotter. This is the latest update of the data for global average surface temperature released last Friday by the Goddard Institute for Space Studies, so it includes the data for the complete year 2007. It's now clear that 2007 is in a tie for the second hottest year with 1998. 2005 was the hottest. And the 14 hottest years in the instrumental record going back to 1880, when there were first enough thermometer measurements to define meaningfully a global average surface temperature, the 14 hottest years in that whole record all occurred since 1990, 24 out of the 25 hottest since 1980. What's happening reverses a long cooling trend. These are data from the National Research Council study of the famous hockey stick controversy. You can see that the temperature was declining from the proxy reconstructions of global surface temperature, declining till around 1600, leveled off, then started to rise after 1700 and more sharply after 1800. And the key point is we know why. Those key greenhouse gas increases were without question caused by human activities. You look at the spike in those concentrations, the carbon dioxide on top, the methane on the bottom, that came with the rise of industrial human activity. It's absolutely striking. And we know, in fact, that humans are responsible for the CO2 spike because the fossil CO2 lacks carbon-14, and you can actually see the signal of the dilution of the atmospheric concentration of carbon-14 over time as fossil fuel burning grew. I call this the smoking gun of human influence. The top panel shows the best estimates of human and natural forcings from 1880 to 2005. The bottom panel, a state-of-the-art climate model, that of the Goddard Institute, this is Jim Hansen and colleagues, fed those forcings reproduces with astonishing fidelity the last 125 years of observed temperatures. Current heating, as I've already indicated, is not uniform geographically. This is data, not forecasting. This is 2001 to 2005 compared to a reference period from 51 to 80. The overall increase in this period was about half a degree C, but what you see is that the increase mid-continent was higher, mid-continent at high latitudes higher still, to the point where the increase in the Arctic was in the range of 3 to 4 times the average increase over this period. That's one of the reasons the Arctic is the canary in the coal mine, the bellwether that's telling us where this is going. Evaporation and precipitation are increasing on the average, as you would expect in a warmer world, but not everywhere, as you would expect in a non-uniform world. Some places are getting drier, even as the world as a whole is getting wetter. In addition, more and more of the precipitation is falling in extreme events, as is also predicted by basic climate science. Permafrost is thawing. This is the average ground temperature near Fairbanks, Alaska. When it gets to 0 degrees C, the permafrost thaws. Arctic summer sea ice is disappearing. We've all seen pictures of this sort. This is September 2005, which was a record low extent of summer Arctic sea ice at that time. And then what happened to that record in this past summer of 2007? The record absolutely shattered, astonishing just about everybody. Surface melting on Greenland is expanding. 1992 on the left. 2002 in the middle set a record. That record was shattered in 2005. Sea level is rising, as you would expect from the rate in the last decade has been about twice the average for the 20th century. Those changes are already causing harm. This shows major floods plotted by decade and by continent from the 50s up through the 90s. Consistent upward trend everywhere except in Oceania. Wildfires in the western United States, 4-fold increase in the last 30 years. These are Kerry Emanuel's data from MIT on the correlation between the total power released by tropical cyclones and sea surface temperatures in the cyclone-forming regions of the world. This connection is still somewhat controversial, although even the rather conservative IPCC concluded there was a better than 2/3 chance that this trend will continue into the future. That is, that there is a correlation between sea surface temperatures increasing under global climatic disruption and the total power dissipated by tropical storms. That weakening East Asia monsoon that I mentioned a few minutes ago has already meant less moisture flow from south to north over China, producing increased flooding in the south and drought in the north. The Amazon is drying and burning. The drying results from the combined effects of regional atmospheric circulation changes linked to global climate change and the local influence of deforestation itself. The result is that parts of the humid tropics, not just in the Amazon, but also in Indonesia and Malaysia, that were previously too wet to burn, are now periodically burning, and when they do, launching additional carbon dioxide into the atmosphere. In a bad year, another 1 billion tons of carbon can go into the atmosphere just from the burning. Mitigation do we need and how soon? The Framework Convention I already mentioned, the law of the land in 191 countries, including the United States, as a ratified international treaty, but I suggest that many of our political leaders have forgotten that it's the law of the land, if they ever really recognized it. It calls for stabilization at a level that prevents dangerous anthropogenic interference, of course. There's still no official consensus, but I suggest, as I said in my summary up front, that by any reasonable definition of the word dangerous, the current level of interference is already dangerous. The question is, can we avoid catastrophe? And in that connection, we need to understand that the average global surface temperature, that index of the state of the climate, will rise something in the order of half a degree C more to something like 1.4 degrees C above the pre-industrial level, even if the concentrations could be stabilized instantaneously where they are today. The reason for that is the thermal lag of the oceans. The oceans have a huge heat capacity. It takes them a long time to catch up with changes you've imposed on the radiation balance of the atmosphere.